I'm going to be talking about glycolysis or non-oxidative glycolysis. This happens in the cytosol and no oxygen is involved. It's anaerobic. To start, we start with glucose, which is a 6-carbon molecule, and hexokinase, with the help of ATP, will convert this to glucose 6-phosphate, again, still 6-carbon. And then phosphoglucoisomerase will convert that to fructose 6-phosphate, still 6-carbon. And then phosphofructokinase will convert that to fructose 1,6-bisphosphate with the help of ATP. And this is energy investment phase, as we can see here. And then aldose will convert our fructose 1,6-bisphosphate to dihydroxyacetone phosphate, which is a 3-carbon molecule, and it converts it into glyceraldehyde 3-phosphate as well. It splits that into 2 3-carbon molecules. And then triose phosphate isomerase will isomerase the dihydroxyacetone to glyceraldehyde 3-phosphate. And then the same thing is happening on each side from here on out. And those two steps are the cleavage phase. And then our glyceraldehyde 3-phosphate produces NADH from NAD plus via the glyceraldehyde 3-phosphate dehydrogenase enzyme, and it gets converted to 1,3-bisphosphoglycerate. Then with phosphoglycerokinase, makes an ATP and converts our 1,3-bisphosphoglycerate to 3-phosphoglycerate. Then glyceromutase converts that to 2-phosphoglycerate. And then enolase produces water and converts it to phosphoenol pyruvate. And then we make another ATP via the pyruvate kinase, and we end up with pyruvate, which is a 3-carbon molecule. And this is the energy liberation phase as we are making ATP. So at the end of this, we are ending up with glucose, or we convert glucose into 2 pyruvates, and we're making a total of 2 ATPs because we invested 2 in the beginning, and then we make 4. So we make a total of 2 ATPs, and we make 2 NADHs as well, which are energy electron carriers. So to talk a little bit about how high intensity training can change glycolytic capacity. When we're doing high intensity interval exercises, there's increased enzyme activity because there is a surge in energy demand when you're doing these activities. So that there's an increased activation of enzymes involved in glycolysis, such as hexokinase, phosphofructose kinase, and pyruvate kinase, and the repeated stimulation of these enzymes during high intensity intervals can enhance their activity levels and then thereby improving glycolytic capacity. Also, high intensity training promotes muscle fiber adaptations that can enhance glycolytic capacity. High intensity exercise recruits fast twitch muscle fibers, which have a greater resilience on glycolysis for ATP production compared to slow twitch fibers. With regular HIIT training, there can be increased in the proportion of the size of this fast twitch muscle fibers, leading to an overall improvement in glycolytic capacity. And finally, intense exercise depletes muscle glycogen stores because this is our stored muscle and it's using that immediate energy, which leads to an upregulation of enzymes involved in glycogenolysis, which is the breakdown of glycogen into glucose. And so with the repeated high intensity exercises, the muscles become more efficient at mobilizing and utilizing glucose and glycogen, which again is going to improve glycolytic capacity. So overall, during high intensity interval training, we're going to have improved glycolytic capacity in order to mobilize our energy stores more efficiently, as well as go through glycolysis more efficiently as well when we have high energy demands. To speak a little bit about alternate pathways with glycolysis, lactate forms when NADH oxidation does not keep pace with its formation in glycolysis. So if the glycolytic rate is greater than the mitochondrial respiration rate, NADH is oxidized and pyruvate is reduced to lactate in the cytoplasm. So this is done via lactate dehydrogenase. It converts an NADH to NAD and we get lactate to pyruvate. So essentially we have 3 fates of lactate. We can have oxidation at the site of production or oxidation at adjacent or distant sites via the cell-cell lactate shuttle. And then we have the Cori cycle, which is used by the liver to make new glucose. So that's the basic basis of glycolysis and non-oxidative glycolysis and the fates of the products of glycolysis, such as pyruvate, potentially into lactate or vice versa.